All right, let's start with inequality. So we are going to learn two types of inequality today. One is with the line, second with the absolute value. First, let's do this example. Graph y greater than 3x minus 1. What you want to do is you want to just graph it as if it were a regular line. So y equals 3x minus 1 would look like what? So go ahead and graph that. 3x minus 1. So first thing is you graph that boundary line. 3x minus 1, what number should you start graphing from? Negative 1 on what? Yes. Okay, I'm seeing a lot of wrong things. You either went to x-axis or you went up 1. So please review previous sections. You have to remember how to graph a line. Okay, and then you have to graph the slope. That's rise 3 over 1. Okay, now we know that this line will connect like this. However, this is an inequality, so we cannot just graph a straight line or a solid line. We have to check. So if it's greater than or less than, we're going to use dotted lines. If it's greater than or equal to or less than or equal to, we're going to use solid line. So in this case, is it going to be dotted or solid? Dotted, very good. So we're going to put dotted lines on here. We're saying it's not equal to, so we're not going to include that line. Okay, the next thing is when it's inequality, we're going to have to shade. So we're going to have to choose a side to shade. Usually, your book will tell you use a test point. So usually I use 0, 0. And I plug it into the function to see if it's true. So what you do is you plug in 0 into x, 0 into y. So that's going to be 0 greater than 3 times 0 minus 1. So 0 greater than minus 1. And then you ask yourself, is that true? Is 0 greater than negative 1? Yes. So then what you're going to do is you're going to shade the side that has 0, 0. Okay, so that's one way to do it. The other way to do it, which most people do instead of using a test point, is they ask themselves, is it greater than or less than? If it's greater than, you shade up. If it's less than, you shade down. So up means that you're going to shade this side because it's higher. Like if you split it, it's a little higher than the other side. So shade up means that way. So most people do it this way instead of using a test point. But if you really, really don't know, then you use a test point. Let me ask you an additional question that's a little bit tricky. Let's say this point here, 2, 5. We're right on the line. Talk to your partner. Is 2, 5 a solution in this? Let's do an easy one first. Let's say negative 2, 4. Okay, talk to your partner. Is negative 2, 4 a solution to this inequality? Is negative 2, 4 a solution to this inequality? So talk to your partner. Is negative 2, 4 a solution to this inequality? And why not? Why or why not? Okay, negative 2, 4. How many people say yes, that is a solution? How many people say no, it's not a solution? Okay. Yes, it is a solution. Why is that? It's in the shaded area, correct. Now, let's do one that's on the boundary line. Let's talk to your partner. Is 2, 5 a solution? Talk to your partner. Is 2, 5 a solution? No. All right, let's check. Okay, 2, 5. Is 2, 5 a solution? Yes, raise your hand. No, raise your hand. Okay, it's not a solution, but why? Yes?
Because y has to be greater, and since 2, 5 is on the line, it's like not, y can't be greater.
Yes, correct. So if it's a dashed line, you cannot be on the dashed line. It's basically saying that's an invisible line that does not include, so you cannot be on the line. So 2, 5 is not part of the solution. Yes?
How do you find out if it's a solution?
If it's in the shaded area, it is a solution.
If it's not.
Yeah, if it's not a solution. If it's here in this white region, no, it's not. And this one is a greater than, that's why we have a dotted line. So if you're on the dotted line, you're not part of the solution. However, when it's a solid line, on the solid line is a solution. Because it's okay to be on the line. Yes?
So it says if it's true statement, shade the side with the point.
Yes, shade the side with the point means the shaded area is the entire solution, which is everything that's in the shaded area.
So how would you decide which is the shaded side?
Well, there's two ways. One, you put in 0, 0, and then if 0, 0 is making that statement true, you shade the side with 0, 0.
Oh, okay.
Or you look at it and say, oh, it's greater than, so you shade up.
Okay.
Okay, let's try another one. All right, let's have you guys try this one. 3x minus 1, same equation, but we are going to look at less than or equal to. Let me know when you're done. Okay, so we're going to start, for number 2, we're going to start in, -1, and it goes up 3 over 1, same as before. But this one's a less than or equal to, so that's going to be a solid line. And that is less than, so we're going to shade down. If you're not sure about shading up and down, you can always put in a test point, 0, 0, and check. Okay, number 3, you need to change it into y equals mx plus b first. So that's minus 2x minus 1. So you're going to start at -1, goes down 2 over 1. This one is also a solid line because it's greater than or equal to. So since it's greater, we're going to shade up. Okay, the next thing we're going to do is absolute value. So recall from last week how to graph an absolute value. So you're going to start with the vertex, graph the slope, reflect it over, and if it's going to be less than or greater than, it's going to be dotted lines. If it's less than equal to, greater than equal to, it's going to be solid line. Okay, so if you look at this equation here, where is the vertex? -2, -1. What is the slope? 1. Is this going to be solid or dotted line? Dotted. So it's going to be like this. And then reflect it on the other side. Is this going to shade up or down?
Down.
Down. Good? Okay, let's have you guys try one. So same thing as last week. Make sure you change it into the standard or general form before you start figuring out the vertex. Okay, so let's look at this question. First, you need to change it into general form. So that's -y less than equal to absolute value x minus 3 minus 1. Now, there is a negative in front of the y, so we need to divide by -1 to change the sign. Now, when we change the sign, this sign changes too, and then every sign will change. So kind of review from last chapter. Now, the vertex is going to be 3, 1. And it has a slope of down -1. So it's going to go this way. It is a solid line because it's greater than or equal to. And we are going to shade up. Okay. The last thing is this one. This one's a little bit strange. There is a negative inside. Negative inside means we have a reflection over the y-axis. So this is a little different from before. Anytime you have a number in front of x, what you're going to do is you're going to factor. So we're going to take out that negative in front of the x. So that means we're going to divide each term by -1. If you still remember from last chapter, we're distributing out or factoring out the -1. So negative x divided by -1 is what? Okay, good? X. And then 4 divided by -1 is -4. So this is how it looks like. And then there's a, so if you don't do that, your vertex will be in the wrong place. So you have to do that. So please be careful. The next thing we're going to do is that negative inside is a little bit awkward. And now we remember that anytime you have an absolute value, it turns everything positive. So actually it does turn that negative into a positive part. So basically this becomes y and greater than. Basically, we can split out the -1 from the x minus 4. So it actually becomes x minus 4 plus 1. So basically, that negative inside is just gone. If you want to keep it, you can keep it. It's going to reflect over itself on the y-axis, so it's going to look the same. But anyways, it's going to look like this. So now the vertex is at 4, 1. If you didn't do that, you would think it's at -4, 1, but it will be wrong. Please be careful. And then you just graph that. All right, go ahead and graph this. Let me check it, and then submit your notes.